Our second lesson is going to be talking about quotient powers. A quotient power is when we have a base raised to an exponent that's being divided by the same base raised to a different exponent. Like this, x to the fourth is being divided by x squared. There's two different ways you can think about this. The first way is to write it out like this, x times x times x times x all over x times x. Now we can see that we have 4 x's multiplying themselves on the top and 2 x's multiplying themselves on the bottom. We have to remember that if we have something on the top and something on the bottom being multiplied or divided, then that means they can cancel out and go away. And we're left over with simply x squared. Another way of thinking of that is to realize what we can do is if we have an exponent that's being divided, remember how yesterday we added the powers? Now we subtract them. So we take the top power and subtract the bottom power. So now we have x to the 4 minus 2, which we rewrite and simplify as x squared. Both of these things are the same answer, but the reason we want to do it like this is because sometimes we're going to have really big powers that don't easily simplify like this. For example, what if we have x to the 74 over x to the 62? Well, there's no way I want to go through and write out 74 x's on the top and 62 x's on the bottom and then go ahead and cancel all that out. That would take forever. So what I'm going to do instead is remember that because it's being divided, because we have the same base raised to different exponents but one of them is dividing, we can rewrite it as x to the 74 minus 62 or x to the 12th power. Part 2 of this lesson has to do with 0th powers, which are really simple and will take about 3 seconds of your time. Anytime anything is raised to the 0th power, that simply becomes 1. So the rule is that if you have anything raised to the 0, it just becomes 1. If you have x squared, y 7, but it's all raised to the 0, it just becomes 1. If you have 34 raised to the 0th power, that just becomes 1. If we're trying to simplify this, the first thing we do is recognize that this doesn't matter. If it becomes 1, it just kind of goes away, because if you multiply anything by 1, it stays the same. So we get 1 x squared y, and because they're multiplying to the 5 plus 1, this becomes rewritten as x squared y to the 6th. The last thing we have to talk about is a little bit more difficult, and it takes 2 parts. So when we have negative powers, let's say for example we just have x to the negative 2, and we want to simplify that entire. So let's say that we have x to the negative 2 y to the 3rd, and we want to rewrite that simplified so that there are no negative powers. From now on, simplified is going to have to mean that there are no negative exponents at all. Well, what I want you to remember for this lesson, and probably forever for all the time you have to use exponents, anytime that you have some multiplication thing hanging out here and it's not over anything, there's no denominator, we're actually going to have to write a secret denominator. It's all over 1. When we rewrite negative exponents, what we have to do is take whatever chunk is being raised to the negative power, so notice that I did not include y to the 3rd, and I simply flip it over the bar, it jumps, and I have y to the 3rd, which doesn't change, but now this jumps down into the denominator. It's going to change whatever side of the bar that it's on, and it will go down here and become x squared in the denominator. Now, I rewrote the 1 here, but now that you have something else in the denominator, you can actually just go ahead and erase that 1. It just goes away. Let's look at this. This is not fully simplified, because to be fully simplified, all the exponents have to be positive. We see that this chunk here is raised to a negative power, so you see the negatives not touching the x to the 5th. X to the 5th is already fully simplified, you can't do anything else with that. But 3 to the negative 2, I want to get rid of this negative here. So what I'm going to do is I'm going to have it jump into the numerator, and now the exponent becomes positive. It changes its sign. And we have 3 to the 2nd power over x to the 5th. We know that 3 to the 2nd power is 9, so this fully simplifies to 9 over x to the 5th. Alright, here's our last example. Let's say that we have to simplify this, x to the 7th times y to the negative 1 over x to the negative 4th. Well, the first thing we can say is there's 2 ways to actually simplify this part here. The first way is to say, great, I want to see all of these negative exponents here become positive. So I have to flip them over the bar so that I can make them positive. So this will then become x to the 7th, x to the 4th, all over y to the 1. Then what I could do is, just like I did yesterday, combine, because these are multiplying, x to the 7 plus 4, or x to the 11th, all over y to the 1. The other way to do it is almost the same. We're going to say, okay, I want to make sure I flip that to the other side. So I have x to the 7th over x to the negative 4, y to the minus 1. What I could say with this is, using the quotient rule, I know that if I'm dividing exponential expressions that have the same base, I could say, if I have to subtract the exponents, I could say this is x to the 7 minus negative 4, which then equals x to the 11th, which is the same thing I got over here. When I do that, I'll get x to the 11th, y to the negative 1, and then I'll do the same thing. Flip this down over the secret denominator, and I'll also get x to the 11th, y to the positive 1. Both times, you'll get the same answer. It's really up to you to decide how you want to do it.